Welcome to lecture 15 of the course CS213 Object-Oriented Programming of the Cohort University of Science and Technology. In this lecture we will talk about the instance of operator as part of our discussion of polymorphism from our previous lectures. We may also discuss packages and access modifiers in the context of inheritance and polymorphism. The relevant material for this lecture can be found in our reference book Java How to Program Early Objects version, Detail and Detail, in chapter 10 of the book. You can also find the relevant material in other tutorials online. Some of the links have been given over here, and the relevant topics for this lecture or the instance of operator can be seen on the slide as well. We have discussed some of these topics and some we will discuss in the upcoming lectures or maybe in this lecture. The instance of operator in Java is used to test whether the object is an instance of the specified type. If we want to check that an object is an instance of a class or a subclass or an interface, we can use the instance of operator. It is also known as the comparison operator because it compares the instance with the type. The type in this case is the class or a subclass or the interface. So if you want to check that if an object is, for example, is an object of a particular class, we will compare it with that class using the instance of operator. If it is true, then it will return a true. If it is false, then it will return a false. If we apply the instance of operator with any variable that has null value, it returns a false. For example, consider the following hierarchy. We have a class P that has a bunch of subclasses. In this case, it has a subclass student and it has a subclass employee. Student has its own subclass tertiary student and college student. The person has an object P. Now, P is an instance of the person class, but P is not an instance of the student class or the employee class. So if you want to confirm that if P is an instance of the person class or the student class or the employee class, we can use the instance of operator. These print statements should return a true or a false statement to us. It should print these statements. In the first case, we understand that P is an instance of the person class, as we can see over here. It should return a true. The second case, P instance of a student, which is not the case, and it should return a false. Same is for the third example, that P is not an instance of the employee class and it should return a false. Similarly, if we have in the same example, if we declare an object for the student class now, and S is an instance of the person as well as the student class. Why? Because an object of the subclass is an object of the superclass. The student class is a subclass of the person class. So we can say that S is now an object of the student class as well as S is an object of the person class. But student and employee are incompatible types. If we try to compare the student object with the employee class, the compile will generate an error because there is no reason to compare the student object with the employee class. The compiler will not allow it because they are not compatible. It is like comparing an integer with a string. They are completely irrelevant from each other. We cannot use the instance of operator between S and the employee class. S is an object of the student class, which is a subclass of the person class. So there is a relationship between the student class and the person class, but there is no horizontal relationship between these two classes. So the first two statements should return a true. The third will not return a false. It will not execute. It is an incompatible comparison. It is a comparison between two classes or an object of a class or a class that are not compatible with each other because student S is an object of the student class, which is a subclass of the person class but has no direct relationship with the employee class. To extend the example further, create a student object but with a person reference. Now we can use, of course, the superclass reference to declare an object for the subclass. As in this case, we can use the person class reference to declare an object of the subclass. Now again, P1 is an instance of the person class and the student class. P1, the P should be smaller, but P1 is not an instance of the employee class. Here, since there we are using the superclass reference, now we will not get the compatibility error because employee is an object is a subclass of the person class, and we are declaring this object using the person class reference. Therefore, we will not get an error, we will get a false output for this comparison because P1 is not an instance of the employee class, that is why we get a false. But as opposed to the previous case where we were getting a compiler error, in this case we will not get a compiler error P1 because P1 is declared as a person. Therefore we can use the instance of operator between P1 and employee, since person P1 is used to declare as an object of the student class using a reference to the person class, that is a superclass of both the employee class and the student class. Extending the example further, we use the subclass of the student class to declare an object TS in this case. Now TS is an instance of the person, student and the tertiary student classes because student is a subclass of the person class and tertiary student is a subclass of the student class. So the TS operator that is declared using the tertiary student reference is a subclass of the student class, which in turn is a subclass is an object of the tertiary student class, which in turn is an object of the student class and also is is an object of the person class. But tertiary student, as we can see, has no relationship with the college student. These are incompatible with each other. We cannot, let's say, compare the TS object with the college student or the employee class. Tertiary student and employee are incompatible types. We will get compilation errors for these two comparisons, and we should get a true for this one. As you can see, we get a true output for this comparison, but this will not be compared and we will get a compiler error because tertiary student is used to declare this object which has no direct relationship with the college student or the employee class. Again, let's further extend the example. Create a tertiary student object but with the student reference. Now what should happen is we should be able to compare this S2 object with the college student, but we cannot compare S2 object with the employee class. S2 is an instance of person, student and tertiary student, so this statement should return a true. If we say that S2 is instance of, let's say, student, that should also return a true. But as opposed to the previous case, if we say s2 instance of college student, this will not generate an error this time. It will return a false. S2 declares a student, therefore we can use the instance of operator between S2 and college student, but we cannot do the same for the employee and uh, class. Student and employee are incompatible types, so we cannot use instance of between S2 and the employee class. This will generate an error since S2 is an object of the student class, which is a superclass of the tertiary student class. A tertiary student class is a subclass of the student class, which is the superclass of the college student class. So there is a distant relationship between these two classes. Therefore, we can use it for comparison, which will return false to us. So to check your understanding of polymorphism, it's a simple example. If you can guess the output of this program before you run this program, we have a class vehicle and it has a method move that prints some statement, and we have a class car that extends the vehicle class and it has the same move method and it has its own print statement, as well as there is a call to the superclass's move method. We declare an object of the car class using a reference to the superclass vehicle, and then we call that object to call the we use that object to call the move method. You need to guess which method will be called and what should be the output of this program. So we'll go to packages again and we'll have a look at how we can manage our programs better when we have superclasses and subclasses, and how they are related to each other and how we can manage them using packages. We have discussed and seen what packages are and what they are used for, but we'll see them again when we use inheritance and polymorphism. What is the role of a package and why it is important to use packages properly for proper management and understanding of our programs. A package, as we understand it, is a grouping of related types providing access, protection, and namespace management. In simple terms, a package is a namespace that organizes a set of related classes and interfaces. Related types in this case can be called as like classes, interfaces, enums, etc. The purpose of a package is to make types easier to find and use, to avoid naming conflicts, and to control access. Programmers bundle groups of related types into packages. Conceptually, you can think of packages as being similar to different folders on your computer. Now, if you remember in our earlier classes, we were creating our program using the console, and then we were creating our files in folders, and then we would access those folders using the command line interface. Now, those folders can be called as packages that contain our files, and those files were our class files and Java files. We will look at that in upcoming slides, but I'm sure, I hope that you remember how to create a class using the folders and the notepad. So note that types refer to classes interfaces. Examples: java.io, file operations, it is used for file operations. So Java is a folder that contains the IO class. The Java can be called a package that contains the IO class. Java.lang, Java is a folder that contains the lang class, basic language functionality and fundamental types. So if we want to use this, we can import these classes into our programs. Java.util, Java is a package that contains the util class, Java collection, Java structure classes. And if we want to use any of the classes or subclasses of the util class, we can import using the import java.util statement. Similarly, java.awt will help us import the basic hierarchy of packages for native GUI components or GUI components. Creating a package. To create a package, you need to choose a name for the package or the folder and put a package statement with that name of at the top of every source file. If you have seen in your programs, you will notice that there is a name of the package at the top of your source file, like this package X. That is the name. X is the name of the package where you are creating your program. That contains the types that you want to include in the package. The types in our case has been the classes that we have been creating. Rules: there can be only one package statement in each source file, so you cannot say package X and package Y. You cannot have these lines in your source, more than one line in your source file, and must be the first line in the source file. For example, you cannot have the same file in two different folders. You can have a copy, but the exact same file will be in can possibly be in only one folder. That is why we can have a class or a file or a source file in only one package. If you put multiple types in a single source file, only one can be public, and it must have the same name as the source file. If you remember, we have been saving our class names, our classes with the same name as our classes. So the name of our Java file and our class name are always the same, and that name has always been declared as public, that type, and which has been in our case the class. So we have always declared our classes as public, and we can only have one public class in one file. It must have the same name as the source file, and the reason for that is that we are going to save that file with the name of that class. We can include non-public types, for example non-public classes, if we need, in that same file, but it will have a public type, a public class, and it can only have one public class. Why do we need to include non-public types? We may use some of the examples where we need to include more than one classes in one single file, where only one will be public and the rest will be non-public. And why do we need to make our class public? This rule makes it easy for the class loader and the human programmer to find the definition for a public type. So if we need to look for that class, we can write the name of that class and we can import that class into another program, etc. If you put multiple types in a single source file, only one can be public, and it must have the same name as the source file. So the public class, the name of our file has always be the same as our class name. You can define public class circle in circle.java. That is what we have been doing from our first class. Define public interface draggable in the file draggable.java. Interfaces are we are going to discuss in our upcoming lectures. Public enum day in the file day.java. So enum is another type that we can use for our file names. You can include non-public types in the same file as a public type, although this is strongly discouraged unless the non-public types are small and closely related to the public type. But only the public type will be accessible from outside of the class. So if even we have a non-public class with a public class in the same file, we cannot access that non-public class from outside of that package. You can only access the public class from outside of the package. All the top level non-public types will be package private, which means that we cannot access those non-public types from outside of the package. This rule makes it easy for the class loader and the human programmer to find the definition for a public type. So for example, if we need that class from outside of the class in another program, we can use or import that class using the import statement and the name of the package and dot separated by a dot and the name of the class. The name of a package determines the directory in which the files of this package should be stored. So it's simply a folder that contains all our files. The name of a public type determines the name of the file in which the type's definition must be found. So the file name that we have been using, for example, the circle.java or the car.java, is basically the same as our class name that we have been only using the class types so far. So we can say that we always save our class with the same name as our file with the same name as our class name. The default package, although if you are using an IDE for example, it allows you to declare a package for you by default. Now you can use the default package and you can create programs in that. You have been doing that, but it is okay for smaller programs. But if you want to use, let's say, your code in some other program, you won't be able to do that with a default package. If you do not use a package statement, your type ends up in an unnamed package. There is no name for the package. It is an unnamed package. You can do that in the IDEs, but there are problems with that if you want to export that class or import that class into some other class or program. Generally speaking, an unnamed package is only for small or temporary applications or when you are just beginning the development process. You are always advised to create the package first, and we have been doing that in our examples, and we will look at that when we discuss an example in the upcoming lecture. Otherwise, classes and interfaces belong in the name packages. We should always create our package first, and then we can include classes, interface, and other types that we want to use in that program. Package naming conflicts with programmers worldwide writing classes and interfaces using the Java programming language. It is likely that many programmers will use the same name for different types. The compiler allows both classes to have the same name if they are in different packages. So if you are creating a program that both of the programs need to have the same class names, let's say both of the programs have the car, you are creating two different games, both of the games have cars, you can have a car class in both of the programs if you use different package names. The fully qualified name of each rectangle class includes the package name. So if we want to use the complete name of a class, that will be identified by its package. That is, the fully qualified name of the rectangle class in the graphics package is graphics.rectangle, and the fully qualified name of the rectangle class in the java.awt package is java.awt.rectangle. External references. To use a public package member from outside its package, you must do one of the following. The fully qualified name for class C in package P1 is p1.c. So if you want to access a class from outside of its package, you will need to use the name of the package with the name of that class. To import class C from package P1, you write import p1.c. To import an entire package P1, you write import p1.static. That will import all of the classes in the P1 package. For example, we have a package P1 that is shown by the folder. So the folders are basically our packages that can contain different classes. Directory package p1, that is the name of our folder. It has a class protection, and then there is class 1, there is class 2. Package p1 has class protection. Public class 1 tries to access. If we want to, let's say for example, here we can see that we are accessing the protection class in class 1. So we can access, and the class 1 and class 2 are outside of this package p1. So if you want to access the protection class from outside of the class, for example, let's say in this class 1, we can use the name of the package followed by the name of the class separated by a dot operator. p1 dot protection will help us declare an object of the protection class in class 1 that is outside of the p1 package. So we can see that we can declare an object of the protection class, that is C, using p1.protection. C is equal to new p1.protection. It will declare an object of the protection class in class 1. Similarly, once we import the package or import all of the files of the package p1, we can directly declare the object of the protection class. Now we do not need to access that class using the p1 dot operator. Using the dot operator, we can directly access the protection class since we have imported all of the files of the p1 package into the class 2 file. So in this video we talked about the instance of operators, and then we discussed the packages in the context of inheritance and polymorphism. In the next video of this lecture we will talk about access modifiers. So see you in the next video.